Hello everyone. As per our promise, we are going to start video lecture series on geography. And today we will start directly with the atmosphere and its composition. The reason is quite simple. Keeping in the mind in the current scenario, the climate is a hot topic of debate. And the second factor is that in nowadays in exams, the exams focus the climatic portion of the geography more often than any other portion of geography. Combining these two factors, I decided that we should start with the climate and with the introduction of atmosphere and its composition. The very first question that comes to mind, what is atmosphere? So atmosphere is a mixture of different gases, water vapors and dust particles, which envelops earth all around. मतलब एटमॉस्फेयर जो है ये बहुत सारे गैसेस से मिलकर बनता है। इसमें वाटर वेपर्स होते हैं, डस्ट पार्टिकल्स होते हैं और ये अर्थ को चारों ओर से घेर कर रखते हैं। तो सबसे पहली बात जो हमें समझनी थी वो ये थी। वन बाय वन वी विल स्टडी डिफरेंट कंपोनेंट्स ऑफ द एटमॉस्फेयर, द एयर, द वाटर, द डस्ट पार्टिकल्स। But first of all, we should study about the air and the different aspects of atmosphere related to air. Air is mixture of different gases. The different gas lies in different layers. This is because of their densities. The difference in their density decides which gas will be more prevalent in which of the layer of the atmosphere. Or you can say layering of the atmosphere itself is a consequence of the difference in the densities of the gases. So let us start one by one, and first of all let us start with the composition of different air, the proportion of different gases in the lower layer of atmosphere. There is a trick where we will try to learn that what is the approximate proportion of different gas. And the first trick is saying no AC. The word no AC. Today is World Environment Day, and keeping in the mind the environment factor, we will learn about no AC. Saying no to AC is the trick. N stands for nitrogen gas, which is approximate 78% by volume. O is the oxygen gas, 21% approximate. A is for argon, the argon gas, argon. This is approximate 0.9%. And then carbon dioxide, CO2, which is approximate 0.3%. And there are several other traces of gas like neon, helium, krypton, xenon and hydrogen. If you look at them carefully, and if you know slight of the things or very little about the chemistry, then you will remind yourself that there is a group number 18 in the periodic table of chemistry which explains about the noble gases helium, neon, argon, krypton, xenon. These are the gases which are prevalent: argon, neon, helium, krypton, xenon. They are the stable gases, they are the noble gases which are present in the atmosphere. Hydrogen has a very low density. So because of their density, the gases which are low in densities mostly will be found in the upper layer of atmosphere in much abundance in comparison to the gases which are denser. Now, because of their density, the higher the density of the gas, less is the probability that it will be available in the higher layer of atmosphere. So, oxygen has a very high density. Therefore, the limit of oxygen is up to 120 km from the surface of the earth. And similarly, carbon dioxide exists up to their limit of 90 km from the atmosphere. Now, we will study the two important meteorological gases. One is the carbon dioxide and other is the ozone. Let us start first with the carbon dioxide. Carbon dioxide is meteorologically a very important gas. It has a very crucial role to play in the atmosphere. The first reason is that it is transparent to insolation. What is insolation? Insolation is the incoming solar radiation. The solar radiation coming, they carry energy. Energy E equals to h nu, where nu is the frequency. These radiation, they travel in the form of electromagnetic wave. Now this is just a part of physics. A little bit of knowledge of physics will help you to understand it better. So I said that the carbon dioxide is transparent to insolations, means the incoming solar radiation, they transfer or penetrate through the carbon dioxide and reach the surface of the earth. They are transparent. The carbon dioxide gas is transparent to the incoming solar radiation. The incoming solar radiation, it comes to the surface of the earth in the form of electromagnetic waves, electromagnetic radiations. And the electromagnetic radiations, they carry energy, which can be quantified by the formula E equals to h nu, where h is some constant. It means energy is directly proportional to frequency. Or you can say energy E equals to hc by lambda, where energy is equals to hc by lambda. H is some constant. Let's say c is the velocity of electromagnetic radiation. What is c? C is the velocity with which the electromagnetic radiation travels, or you can say the speed with which electromagnetic radiation travels. So keeping in mind that let h and c be constant, or you can say ceteris paribus, keeping all things constant, the energy is inversely proportional to lambda. What is the meaning of this? Energy is inversely proportional to lambda, and this means that energy is inversely proportional to wavelength of the radiation. Smaller the wavelength of radiation, higher will be the energy. What I said? Smaller the, let me write it here, smaller the wavelength, higher will be the energy. This is the meaning of inverse relation. जितनी ज़्यादा आप वेवलेंथ को छोटी करते जाएंगे, एनर्जी उतनी बड़ी होती जाएगी. So incoming solar radiation, they exist in small waveforms. They have small wavelengths. It means they carry higher energy. And since they carry higher energy and of smaller wavelength, they penetrate through the carbon dioxide. But there is a very important aspect of carbon dioxide, an important characteristic of carbon dioxide, that it is transparent to insolation, however opaque to terrestrial radiation. It means that they do not allow terrestrial radiation to pass through them. It absorbs the terrestrial radiation and reflects some part of it again back to the surface of the earth. Now what is terrestrial radiation? Terrestrial radiation is the energy radiated by earth in long wave form. So this is the energy which is radiated by the earth in the long wave form. Why in long wave form? You can simply analyze it by saying that, or by imagining that, let us say the incoming solar radiations, they are coming with higher energy and they strike on the surface of the earth. After striking the surface of the earth, they loses some part, or they lose some part of its energy, and since some part of energy has been lost, then the amount of energy will be decreased, and since the amount of energy will be decreased and keeping all things constant, meaning ceteris paribus, you will see that the wavelength of the radiation has increased. So the increased wavelength indicates that energy has gone down. So now with the less energy, they try to penetrate the carbon dioxide but unable to penetrate the carbon dioxide, and carbon dioxide absorbs the terrestrial radiation. So in this way, by absorbing the terrestrial radiation, they develop an envelope around the earth and does not allow the energy or the heat to escape from the atmosphere of the earth. And this leads to greenhouse effect, in which the temperature within the surrounding of the earth or within the atmosphere of the earth keeps on increasing because of the increase in carbon dioxide. As the amount of carbon dioxide will increase, more the probability or more the extent of terrestrial radiation being absorbed in the carbon dioxide will increase, and hence the greenhouse effect will increase. This is the major concern nowadays in the international arena. There are several policies, several agreements going on within the government organization at the international levels also. The several policies have been framed just in order to mitigate and reduce the effect of this greenhouse effect. How can we do it? We can achieve it by reducing the extent of carbon dioxide produced by us. You must know that most of the gases, the volume of the most of the gases remain constant. The extent their composition remain constant. However, the carbon dioxide keeps on increasing. and the reason is the burning of fossil fuels, oils, coals, etc. However, if we somehow reduce the extent of carbon dioxide produced by us, then in that case we will reduce the extent of terrestrial radiation that is being absorbed by carbon dioxide, and hence we will reduce the greenhouse effect. Okay, so this was the case of carbon dioxide and the different aspects and different features of carbon dioxide and its consequences of the earth. Because of the greenhouse effect, let me remind you again, because of the greenhouse effect, the overall temperature within the earth's surface increases. Now let us discuss another meteorologically very important gas, ozone. Ozone gas is found between 10 to 15 km from the height or from the surface of the earth. It means from the surface of the earth, within this height 10 to 50 km range, they are found. They act as a filter. It means they allow certain kind of radiations, the incoming solar radiations, to pass through it and absorbs ultraviolet radiations. Ultraviolet radiations, they are harmful for the living organisms. So by absorbing them, the ozone gas acts as a protector. Now look at the second side. What we are doing? By using the refrigerators, air conditioners, deodorants, the substances those contain halogen gases like chlorine. The substances those contains chlorine, fluorines. What they are doing? They are destroying the ozone gases. And with this, since the ozone gas will be destroyed, they will not be able to absorb ultraviolet radiations, and therefore more the disease will be spread. And living organisms, they will feel uncomfortable. So they protect us. Now we are destroying our protector. So it's our job to utilize all those things within the refrigerator, air conditioners, those do not emit the halogen gases or the chlorines, in order to protect the ozone so that it can protect us from the ultraviolet radiations. In the next video, we will discuss about the water, and in the subsequent videos, we will discuss about the dust particles and the structure of the atmosphere.